Alright guys, P, Q and R are points on a horizontal plane. So what we do is we colour code P, Q and R. The three black dots are on the same level, okay? The one dot that's above it is the red dot. So any triangle I make with one red dot and two black dots has to be 90 degrees. Everybody agreed with that? So what are we looking at? 3 and 5. We want to find out what PR is, and we have enough information to find PR. So we're using the triangle PQR. Does everybody see PQR? All three of them are at the same level. They're all on ground level. This means it's a standard triangle. So we're going to use, 5, 3 and 120. We're going to go and use the cosine rule. Is that okay with you guys? So we're going to say x squared equals 5 squared plus 3 squared minus 2 times 5 times 3 cos 120. If anybody has that answer available, that would really streamline the process.
49.
X squared equals 49 and x equals 7. Awesome. Does an answer of x equals 7 make sense? And why does it make sense? Largest angle looks at largest side. 7 is the largest side, 120 is the largest angle. That answer makes perfect sense to me. Alright? Next one. Find DQ correct to the nearest meter. DQ. Which one's DQ? Alright, we'll go back up. And we'll say DQ. Alright, this one here. So there's our target, D to Q. Ah, that's not so bad. What triangle can I use? I'm going to use a right angle triangle. Which triangle do you think is the easiest triangle to use? Alright, why won't I use, I won't use DQR. I'll tell you why. I actually only have one length. I only have 3. And I have no angles and no other information. So DQR is not a good choice. Okay, does everybody see that? Right, would DPQ be a good choice? DPQ. D, P and Q. I know that's 5. It's not a good choice either, is it? There's one that's a really good choice. Which one is it?
DPR.
What? DPR. Why is DPR the best choice?
Right.
You know that's, well, the other one was right angled as well. There's a better reason. You have a 7 and you have the angle and the side, which makes it the perfect choice. And what side does it want from me? Only problem is what's not in here. DQ is not there, but if we find out what DP is, then we can find out what DQ is. So let's start off with finding out what DP is. Now, the reason I knew to find DP, does anybody see what my next step is going to be after this? I'm going to use DPQ. Remember we passed up on that earlier? And so that's DPQ. And, oh no. So what we're going to do with DPQ is we know it's a 90-degree triangle, and we know that PQ is 5. But once we figure out what DP is, we can then figure out what DQ is. Alright, that's a lot of letters, and you're probably not understanding any of what I just said. So let's focus on D to P, which we'll call X. What side is X in this triangle? Opposite, adjacent, or hypotenuse? Opposite and adjacent means what function? Tan what? Equals X over. What's 7 tan 60? 7 root 3. Is it? Alright, great. Now what can I replace this with now, Joe? And the goal of the question is D to Q, which we'll call we'll call it H for hypotenuse. What rule could you use for H? Pythagoras. Put all that into the calculator and square root it for me and let me know what you get. Root 46. And what is root 46 in decimals?
6.78.
Does 6.78 make sense? I don't think it does. Is 7 root 3 not bigger than that? I'd redo that again, lads.
Oh, I know, I forgot.
See how I knew you got it wrong though? Because I knew that it wasn't the largest side in the triangle. So I knew there was a mistake. It has to be the largest side. So what is that? 7 root 3 to be squared plus 5 squared. Anybody else in the house? Did you put it in brackets, Joe? Will you do it now? I'm sorry, wait now. What?
I think it's 173.
And then square root that?
13.41.
Yeah, now that makes sense because the hypotenuse has to be the longest side. Okay? So was your mistake not bracketing that off? Yeah. Alright guys, that's question 5 done. Now we're going to move up to question 8. Or sorry, question, yeah it is question 8, this one. Once again, I'm going to mark off that E and F are at the same level, aren't they? They're at the same height above ground. A, D, B and C, they're all at the same level as well, aren't they? So we got ourselves a rectangle. Okay, the rectangle is A, B, C, D. Okay. Now, what else does it give us? E to F is 12. Okay. If E to F is 12, what's A to B automatically? 12. And D to C? A to D? Grand, right? Now what does it want from us? It wants D to F. Now does everybody see the triangle I'm going to use for D to F? I'm going to use D, F, B. Now what sort of triangle is DFB? One of them is above ground and the other two are on the ground. So whoever said right angle, you nailed it. Has to be a right angle. Two of them above the ground, sorry, two of them on the ground and one of them above ground. So it has to be right angles. Okay? What lengths do we know? We know FB is 5. Unfortunately, we don't know DB. Or do we? How to figure out what DB is? Use Pythagoras' theorem on your rectangle to the left. So DB squared equals 7 squared plus 12 squared. And what you get there? Huh? 193. Okay, square root that. 13.89. 1 decimal place, so 13.9. Okay. Now, what does it want from me? DF, doesn't it? So we're going to do another Pythagoras theorem here. We're going to do DF squared equals 5 squared plus 13.9 squared. And what do we get here? Put all that into the calculator.
219.21.
Yeah, square root it.
14.8.
14.8. Excellent work. Good job. We all right with that? Okay. They're tricky. All right. Who got that far anyway? All right. So if you, good man, Mooney. Now, lads, what's the next thing we have to find? B to D to F. BDF. Oh, just wants this angle here. B to D to F. Just call it angle X. Anybody know how to get that? Tan X equals what, lads? 5 over. So just tan inverse 5 over 13.9. What you get? 19 points? Yeah, does 19.78 make sense? Which angle do you think is larger? The green angle or the blue angle? Why? It looks at 13.9, while angle X only looks at a length of 5. That means it's going to be an extremely small angle, doesn't it? because the other angle is 90 degrees. So therefore, when you get an answer like that, you're reassured you're correct because you're expecting a small angle. Okay? Now, what about FMB? Where's FMB located? Oh, I see it there. F. Now, would everybody agree that M's on the midpoint here? So where can I put M here? Let's get rid of all this for a minute. So what's the location of M on the triangle here? The rectangle. Would everybody agree that's M? How do I calculate the distance B to M? Right. Now, I suppose what you're probably asking yourself is, why am I calculating B to M? Why did I go there? Okay. What angle does it want? FMB. That means I need to use the triangle FMB. What type of triangle is FMB? Once again, why? Two of the sides are on the ground, and one of them is directly above, isn't it? F is directly above B, so that would make it right angled. Okay. And do we know B to M currently? No. How do you get B to M? And what length is C to M?
6.
Half it, isn't it? So let's go for x squared equals 7 squared plus 6 squared. (49 plus 36). What? Square root of 85. What? 9.2. Yeah. Because it's not actually the answer I'm looking for, I can just call this root 85, can't I? Okay. What's F to B? 5. What angle are we looking for? Call it angle M. Is that alright? So what's tan M then? Yeah. And then M. Tan inverse that. I'm expecting a pretty small answer, I'd say. Below 50, below 45, I'd say. 28.5? Right. Now, what we're going to do next, lads, is the following. We are going to oh yeah, we're going to do this, right? So, I'll give you an example. Alright, it's a vertical wall. What would that mean about TS? 4. Okay. There's a lot of angles in there and it's quite confusing, isn't it? Now, look at where the angle starts and ends. So what does that mean about the triangle SOV? S to O to V, lads. What do you reckon there? 60 degrees, yeah? I don't think it is equilateral. I can't tell is the answer. I don't know if it is. Actually doesn't look equilateral. If I was to do a circle maybe. Oh, it's a 3D diagram, never mind. What I'm basically disagreeing with Adam is I don't think there's enough proof that SO is the same length as OV. Was it, Adam, was it? Yeah. I don't think there's enough proof yet, so I'm going to not do that, okay? And let's keep going, right? So that's... both triangles have a lot of information in them, don't they? The two right angle triangles. So let's work on the two right angle triangles. So that's SOV. How many of you guys draw out this triangle separately? Do any of you do that? Where you draw out each triangle separately like I would on the board? Now be honest, hands up who does it. Oh, great. Fair enough. Alright. If you're anything like me, too much lines melts your head and you can't actually think much, right? Now, which line is very important that I get it? Which line links this triangle to this triangle? Is there a common side? What is it? What's it called? Phi. Phi is the important one. Now, Aaron, what function will I use? Sine, cos, or tan? I'm after the yellow line here. Phi. So number 4 would be the opposite, the adjacent, or the hypotenuse. So the angle looks at number 4, doesn't it?
Yeah.
Do you understand what I mean by that?
Opposite.
Opposite, exactly. And what's x? So what function am I going to use? Tan. So it's so, which means opposite and hypotenuse is sine. Ka, which means adjacent and hypotenuse is cos. And toa, which means opposite and adjacent, you use tan. Is that okay? Now, so it's tan 60 degrees equals 4 over x. Lads, what's 4 divided by tan 60? Is it 4 over root 3, is it?
4 over 3 over 3.
Yeah, same thing, yeah. I'll use what your calculator gives it to me as 4 root 3 over 3. Alright. Now lads, rounding off the decimals isn't as accurate as keeping it in third form. Does everybody get that? Keeping it as third form is more accurate. So I'm going to write this as 4 root 3 over 3. Is that okay? What's the grand goal of the question? Find SV. So the whole goal of the question is to find this length here. That's why I'm working on filling in as much information about this triangle as possible. What's the next triangle I'm going to use? Yeah, STO. Alright. So STO. So S, T and O, and we got 30 degrees here, don't we? We have a height of 4. Quivin, which side should I target? Y. Yeah, exactly. It links the information to the triangle you want to get the answer from. So what function are you going to use?
Tan 30 over 4.
Tan 30 equals
4x.
4 over x, and then x is?
X is 4 over tan 30.
Yeah, x comes up here, and then the tan 30 goes down. Okay? So that would be x equals 4 over tan 30. I believe that's 4 root 3, is it? Or 4... Yes, sorry, just 4 root 3. Who got that? Okay. Finally, what rule should we use for SV? Why using the cosine rule, Liam? Yeah, side, angle, side. Basically an angle sandwich, I call it. Okay? So that's what we're going to use here. So what do you reckon? Call this, I don't know, just call it SV, sure. SV squared equals what, lads? Cosine rule? 4 root 3 squared, and then 4 root 3 over 3 squared, yeah. Minus 2, 4 root 3. Somebody throw all that into the calculator for me, save some time. What was it?
44.965.
Square root it.
6.1.
Does 6.1 make sense for an answer? It's not. It's either the smallest angle. Sorry, it's a middle angle, isn't it? 6 degrees is somewhere in the middle. Okay, so it should be comparable in size to the other two. We all good? All right. Yes. Yeah. Good question. Good input. 5, 8, and 12. Yeah.